So let's start with, what is algebra? Well, it's all about using symbols to represent numbers that we don't necessarily know the value of. Usually it's letters, but you could use anything. You could use boxes and stars and question marks if you wanted to. We call these symbols variables because they can vary. A given symbol doesn't have a particular fixed value. So sometimes we use algebra to work out a value that we don't know, and that's known as solving an equation. And sometimes you use it to make calculations where things can change. So for example, the area of any triangle is half base times height, which of course we can write as half BH. B and H are variables because depending on what triangle you're looking at, they can change, can't they? If n is a variable, then n plus 5 means 5 more than n. Take n and add 5 onto it. N minus 3 means 3 less than n. Take n, whatever value that is, and take 3 away from it. 4n, with nothing in between the number and the letter, means 4 times n. N over 2 is n divided by 2, or half of n. And n with this little power of 2 means n squared, or n times itself, n times n. Now, on your handout, you've got a copy of this table. I would like you to pause the video in a moment, and you're going to fill in all the blanks. So when n equals 2, what's n plus 5? What's n minus 3? What's 4n? And so on. When n is 4.5, what are all of those values? And when n is negative 4, what are all of those values? So pause the video now, see if you can fill in the blanks, and press play when you're ready to go through them. Okay, the answers. So when n is 2, n plus 5 is 2 plus 5, which is 7. And n minus 3 is 2 minus 3. 2 take away 3, you get negative 1. 4n is 4 times 2, which is 8. Remember, the 4 and the n together with nothing in between them means multiply. N divided by 2 is 2 divided by 2, which of course is 1. And n squared is n times n, so 2 times 2, which is 4. When n is 4.5, 4.5, n plus 5 is 4.5 plus 5, which gives you 9.5. n minus 3 is 4.5 take away 3, which is 1.5. 4n is 4 times 4.5, which is, if you double it and double it again, that's the same as multiplying by 4, so it gives you 18. N divided by 2 is 4.5 divided by 2, so it's half of 4.5, which is 2.25. And n squared is 4.5 times itself. 4.5 times 4.5 is 20.25. When n is negative 4, if you take negative 4 and you add 5 to it, you get 1. Because it's the same as doing 5 take away 4. Negative 4 plus 5, positive 5, negative 4. If you start with negative 4 and you take away 3, you get negative 7. 4 times negative 4 is negative 16. Negative 4 divided by 2 is negative 2. And negative 4 all squared is negative 4 times negative 4. If you multiply two negatives together, you get a positive, don't you? So it gives you positive 16. If f is 3 and g is 6, what's fg going to be? Again, if you've got the two things written together with no sign and no gap in between them, that means you multiply them. So fg is f times g, which is 3 times 6, which is 18. Now a bit on terminology. So chunks of algebra are called terms. It's sort of like building up words if you're talking about English grammar. So you could have variables, things that they're multiplied by, or powers, indices. Put those together and you get a term. And terms can be built up into expressions, which are kind of like phrases, and then into mathematical sentences, which are formulae or identities or equations and inequalities, though we're not looking at inequalities at the moment. So an example of a formula is speed is distance divided by time. If you know the distance and the time, you can work out the speed. So a formula tells you the relationship between two or more variables. Then we've got identities. For example, t times t is the same as t squared. It's just the same thing written in two different ways. So it doesn't matter what the value of t is, this is always true. And sometimes you might see an identity written with 3 lines. This sign here means is equivalent to rather than an equals sign. Then we've got equations, such as 3d plus 2 equals 11. An equation is often only true for certain values of the variable. If you've only got one unknown variable in there, as we have here, because all the rest is numbers, then you can solve the equation to find the value of that unknown variable. Equation really just means it's got an equals sign in it. So sometimes the word equation can refer to a formula or an identity as well. So an example here, if you think about Pythagoras' theorem, you've got side lengths A, B, and C. Those are all variables. And if you square each of them, you've got A squared, B squared, and C squared. Those are all the terms. If we add A squared and B squared, we get A squared plus B squared, and that's an expression. And then if we write the whole formula, the whole mathematical sentence, it's A squared plus B squared equals C squared. So the equal sign is like the verb in the sentence. And if there's only one value there that you don't know, just like this, if you know 2 of the values, you can work the third one out. If you know 2 of these values, you can use the formula to work the third one out. So if we know A and C, for example, we can substitute in the values for A and for C. And then that means we've got an equation that we can solve to find B. We need to rearrange it to get B on its own, and that will tell us the value of B. So now an activity for you. We have covered most of these terms on the previous slide, so you shouldn't find it too bad. It's on your handout, so I want you to match up a definition and an example to each of these terms. So pause the video, have a go at it, and press play when you're ready to see the answers. Okay then, the answers. So the first one, a variable, is a letter representing a number, or a symbol representing a number sometimes. And the example of a variable here is the one that's just a letter on its own, the n. A term is the building block that you use to form the other things, the expressions, the equations, the identities, and so on. And the term here, where we haven't got things added together and we haven't got an equal sign, it must be the 3a squared. An expression is a combination of algebraic terms. The 3a squared, you could say that's an expression on its own, really. But the key point here is that it doesn't have an equal sign in it. It doesn't make a whole sentence on its own. So here, the 2x plus 3b is the expression in the examples. Equation is often only true for particular values of the variable, and you can solve it to work out the values. Sometimes there's no solution, but usually you will be able to solve them. So which of these looks like something that you could solve to find the value of the variable? Well, this is the only one that only has a single variable in it that will only have a particular value. So this one is the equation. An identity is the one that is true for any value of the variables. Remember, it's just the same thing written in two different ways. Now, which of these is the same thing written in two different ways? A plus A plus A is the same thing as 3A, isn't it? No matter what the value of A is. Then we've got a formula. That's the one that tells you the relationship between two or more variables. So that's this one. And the formula here is this one here. And if L is the length and W is the width, and you've got a rectangle, then 2 times the length plus 2 times the width gives you the perimeter. So that's what this particular formula is for. And finally, we've got a function. You'll have covered function machines in school. A function converts an input variable into an output variable. So x goes into the function machine, gets multiplied by 3, has 2 added to it, and brings out an output, which in this case we're calling y. So that's a function. You are expected to know all those terms, and you might get asked to show your understanding of those in the exam.